3.8 Newton's method. So Newton's method is just a way to calculate, approximate the roots. So we know on quadratics, right, there's an equation for all 3.8. There is an equation that allows us to find all quadratics, right? So we do negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we also, there is a method allows us to find cube roots. So anything to the cube. I maybe see it in college, but I never actually used it. But there is a way to find all cube roots, but nothing higher than that. There's no method in order to find them. There might be a certain type that you can find, but not a general one, right? So when we have a problem like this and we're trying to calculate, okay, how would you find the monthly interest, right? Trying to find this monthly interest x. Well, this is a really complicated equation in order to find out that, right? So Newton's method is a way in order to approximate those roots. So normally when we're talking about roots, we're talking about where on the x-axis does it cross, right? Roots or zeros or solutions, x-intercepts, those type of things. So sometimes they're like if I have 1 and or say 2 and 3, somewhere it's between 2 and 3, right? And so if I don't have rational solutions, which we can come up with rational solutions, right? The factors of the constant divided by the factors of the lead coefficient. We did that a little bit in this chapter of running through those possible rational solutions. But what about the irrational ones? How do we find that? So Newton's method is a way to find that. So first we pick an x that's close to it. So sometimes we might graph these equations and look, okay, what maybe our graphs look like. Or if we have like, so the square root of 100, and say 101 or something like that. And we can use our calculator to approximate that. And your calculator might not use Newton's method, but it probably uses some form. There's a couple others that algebra programs use in order to find out what the roots are. Okay, so one way is to graph it and kind of estimate what this value is that we're going to start with. So here we might try like 2.5. So I want to try 2.5. And I'd use Newton's method. And it would, when I plug in 2.5, it would give me another number, say, okay, maybe it's a little closer, say 2.3. And then you can use that, okay, it's a little closer, 2.25. And then have a next one might be 2.256. And then you get closer and closer to what the actual root is. And you get smaller and smaller numbers. And you want to go out to a certain decimal place or something like that. You'll have these questions that come up. Okay, so let's go through a couple. Let's show you what it is. I'll show you what it is. And so this is Newton's method. So we're given some x value a lot of times. And so that's like x to the n. And we want to get closer and closer to the true value, right? So to find the next x that we're going to use, so to find the next x, that'd be n plus 1, next x value, we would take our first x value and we would subtract the ratio of plugging in that x value into our regular function over plugging into the derivative. Plug it into the derivative. So what we're going to do is we're going to find the regular function and our derivative, and we're going to plug in our x value into the original and into the derivative, find out what that fraction is, and then we're going to take that x value and subtract whatever that function is, and it's going to give us our next x value. Okay, so this is Newton's method, and you keep on doing it until you get to so many decimal places that are correct. Okay, so here's an example of it. This time they give you that first x, right? So when I write this equation, and a lot of times with these calculators you can put all this in here. So that's our original. And then we're going to take our derivative, and that's going to be on the bottom of the fraction. And I'm already do this on underneath here. And then we're going to take that away from our original x, so that would be 2. And that's going to give us our next x value, x2. So what I'm going to do is I'm going to take this 2 and plug it in for all my x's. And then I'm going to go ahead and evaluate this, and that's going to give me my next x. And a lot of times on your calculator you can go ahead and just keep this in there, and all I have to do once I find my answer for the next x, I can come back in here and plug that next x in here, and here, and here, and in here, and find the third one, and keep on going until it wants me to find however many, or to a certain decimal place. This one just wants me to find the third one. Okay, so that means I'm going to have to do this twice. So I take the first derivative, which I already did, and then I can go ahead and apply Newton's method, which I already set it up here. All right, so you can already kind of see that. Already did that up there. So we go ahead and do that. Plug in 1. Oh, I'll plug in 2. Okay. And so that's what this kind of looks like. A long way of looking at it. And so there, we're back to what I already have down. Right? So I want to plug that into the calculator. Might look something like that. Plug in my 2. Evaluating. And I get 2.1. So that's my x. My x2 is 2.1. So now instead of plugging in 2 into all those spots, I'm going to plug in 2.1 into all those spots to find my third x. So what this is doing is just getting closer and closer to that root value. So now I'm going to plug in that number. And like I said, a lot of times you can have this whole thing in your calculator. You know, if you have a TI-83, 83, 84, something higher than that, you can just keep this whole thing in there. On a TI-84, 83, you might be able to hit second or shift equals, and it'll bring back your previous equation. So that might work. So then you don't have to retype this whole thing in again. All I have to do is arrow back, change this number, change this number, change this number, and change this number. Okay, and so this is the value that we want because it only asks for x, the third x. So there it is. Okay, so that's one way to do it if they actually give you that first x value. Well, what if they don't give you the x value? So what you can do here is they actually want us to find this one, this root, the 6th root of 2 to 8 decimal places. So what I can do here is to estimate what this is, I could graph it as, say, y equals 6th root of 2. Or I could rewrite it. So this is just explaining when do I stop. It says to the 8 decimal places. So there I just keep on going until my 8th decimal place is the same. It's repeated, so I might have to do it an extra time. So I could come up with the equation. I could write x equals this and then go ahead and solve for y. Either way, you can do this too. I mean, it's fine. But here's one way. And then you can go ahead and graph that equation. So graph that equation and figure out where it crosses the x-axis. So it might be in between two numbers, say 1 and 2. And then you can zoom in and look for what this number is. Maybe it's like 1.78, and then use that as your first x. But here we could also calculate this on a regular just calculator. So here's kind of the longer way. You might have to go back through this and pause it a few times. But here's our equation that we could work with. Okay, so rework that. And then we can take the derivative of that, which is here, and then we can write Newton's method. I think what I told you in class is you can just take this on a calculator and say whatever you get, 1 point something, maybe 7.8, I don't know. I think that's way off, but it's 1 point something. Anyways, and then just plug that 1 point something into your equation here kind of thing and run that through. And you can use that as your first x. But you do need your equation, so I guess I didn't mention that. So here's your equation right here. So what you have to do is just take this and do the inverse of that, right? So set that equal to x like I did. Go ahead and take the inverse. Now you have 0 equals or y equals, and then you can take the derivative of that. So y prime equals, and then you can go ahead and set up your Newton's method here just like I did here. And then you can enter that first x in. Like I just picked one, x, but you could actually go ahead and take the 6th root of 2 and see what that number is. And enter that number in, then you don't have to do it as many times. Okay, so I picked 1, and I had to run it in quite a bit to find my next x. So I got my x is 1 1/6, and then I got my next x. And so I got to keep on going until my 8th decimal place is the same. So 1, 2, 3, 4, 5, 6, 7, 8. But you notice it just keeps on changing. So then I just keep on going until that they're all the same. So on my 6th one, they became all 8 of them are the same. So then I can stop right there, and that is my number. Okay, so that would be my number that I'm approximating to of the 6th root of 2. So that's how you kind of do it that way. Another way, so this is the same thing. So if you have this type of function, we can go ahead and take that, write the equation, set it equal to 0, and then we can go ahead and take the derivative of that. And then I can set up Newton's method. Right, and here, what I want to do, maybe to find that number, I just guessed, let it be 1. But what you could do is you could graph this on a graphing calculator and estimate where it crosses that line, right? Because the more closer you get originally to it, the less times you have to do Newton's method, right? So you could graph it, see where it's going to cross. So what I did here was I graphed cosine of x, and then I saw where maybe they intersect. That's how I chose my x of 1. And then so I can run that through Newton's method. Here we got to think about, we can put our calculator in radians and go ahead and run it through. And then I'll have to do it 4 times, and that's the number that I get. So those are the different ways that either they give you an x1 equals this, and you have to go to so many, or I might give you something like this, where you can go ahead and estimate that number and then write your equation by taking the inverse, or a trig function, go ahead and set it equal to 0. You could graph it, figure out what that value is getting close to, and use that as your first x. And then make sure you're taking the derivatives of all these equations and then running through Newton's method.